In this lecture video, let's take a look at matrix operation. So the first thing I want to show you is adding and subtracting matrix. So given matrix A and B of like dimension. So that's very important. You got to have a like dimensions in order to add and subtract. All right. Addition and subtraction of matrix A and matrix B will produce a matrix C or matrix D, whatever we want to call the resulting matrix. Okay. So here it says when we do matrix A plus matrix B, let's call the resulting matrix C, such that the way how we add is take the matrix A's ij entry, add on to the matrix B's ij entry. So what that means is for addition and subtraction of matrix, my first row, first column of A will now add or subtract first row, first column of B. So once I add them or subtract them, then my answer will be located at first row, first column of my resulting matrix. So here is a 2 by 2. There are two by 2 matrix. So if I want to add them, all I'm doing is take row 1, column 1 of A, add on to row 1, column 2 of B. Then my answer, whatever that adding is, whatever the sum is, I will put it at row 1, column 1. Okay, so that's what they mean by A of ij entry plus B of ij entry. Therefore, if that's the way we're going to add and subtract, then the two matrix got to have a like dimensions. Okay, so let's quickly do an example here. So, I didn't mean to define A and B here. On your handouts, please change that to a subtraction. Okay, find A plus B and find A minus B. So the two matrix, I'm going to take A plus a B. Then I'm going to do A minus B. All right. Matrix addition is commutative. So that means matrix A plus matrix B is going to be the same answer as matrix B plus matrix A. All right. It's also associative. So if I have 3 matrices to be added together, I can do A. I can take matrix A, add on to matrix B first, and add on to the third matrix. Or I can do B and C first, okay, and then add on to the matrix A. So addition of two matrices is commutative and associative. So let's just take matrix A and into matrix B, okay? So I'm going to kind of circle it. So here is going to be my answer. I can kind of do it just by looking at it. So matrix, so row 1, column 1 of A add on to row 1, column 2, row 1, column 1 of B. So 6 plus 2 plus 6 is going to give me 8. So this is A plus B, okay? All right. Negative 10 plus 10 will be 0, right? Row 1, column 2, add on to row 1, column 2 entry. Negative 2 plus negative 2 is negative 4. All right. Negative 4 plus 0. You know what? To show some work, let me just kind of write this out first. All right. 2 plus 6. All right. I'm going to put my answer right behind here. So that's 8. All right. Row 1, column 2, row 1, column 2, negative 10 plus 10, which is 0. All right. Row 1, column 3, row 1, column 3, negative 2 plus negative 2, negative 4. All right. Row 2, column 1, row 2, column 1, negative 4 plus 0, which will give me negative 4. All right. 3 plus negative 12, which is negative 9. All right. So let's go with row 2, column 2, 10 plus negative 4, which is positive 6. All right. Row 3, column 1, row 3, column 1, 4 plus negative 5, which is negative 1. Negative 2 plus 2, 0. 2 plus negative 2, 0 again. All right, so here is my resulting matrix. All right, let's do subtraction, okay? So subtraction simply means I'm going to Again, row 1, column 1, subtract row 1, column 1 of B. All right, so that's 2 minus 6, negative 10 minus 10. Let's write a few. Negative 2 minus negative 2. So my first row should be negative 8, negative 20, and negative 2 minus negative 2 should be 0. All right, second row with second row, negative 4 minus 0. 3 minus negative 12. 10 minus negative 4. So that should be negative 4, 15, and 14. All right, 4 minus negative 5. Negative 2 minus 2. Negative 2 minus 2. 2 minus negative 2. So that should be 9, negative 4, and positive 4. Okay, that's how we add and subtract matrix. So it's better to write it down, because if I ask you to do B plus A or B minus A, now B minus A is going to be a different resulting matrix as compared to A minus B, okay? All right, another thing I'm going to show you here is called the scalar multiples, okay? So if I take a coefficient and multiply my matrix, okay, then my scalar, the C right here representing the scalar, then will multiply every entry. So this matrix, find 3 times matrix C. 3 times matrix C simply means I will take a 3, multiply every entry of my C. So 3 times negative 3, 3 times 2, 3 times 3, 3 times 5, sorry. And 3 times 4, right? Row 2, column 2 is 4. So my resulting matrix would be negative 9, 6, 15, and 12. All right, that's called a scalar multiplication. Excuse me. All right, let's do scalar multiplication and subtraction here. So 3 times A minus 2 times B. So let me figure out what each one is first, okay? And then we can subtract them. So let's do 3 times A. So take a number 3 times every one of these entry. Let me write a little bigger. This is 3 by 3. Let me write over here a little bit. So that's 3 times 2. 3 times negative 4. 3 times 4. 3 times 3. 3 times negative 2. And then 3 times negative 2. 3 times 10. And 3 times 2. All right, so my 3 times A is going to be 6, negative 12, 12, negative 30, 9, and negative 6. Negative 6, 30, and 6. There you go. All right, that's 3 times A. Now 2 times B. 6, 0, negative 5, 2, 2. I'm going to go ahead and write all this stuff out to show my work. B 10, negative 12. Two, negative 2, negative 4, negative 2. All right, that'd be 12, 0, negative 10. All right, so this is my 2 times B. So now I'm going to take my 3A minus my 2b. So 3a minus 2b. Okay, so that'd be 6 minus 12. You can do it by the row, by the column. It don't really matter. 6 times 12, negative 12 minus 0. All right, 12 minus negative 10. All right, second one, negative 30. Minus 9 minus negative 6 minus 20, negative 24, and 4. All right, 3a, negative 6, 30, and 6 minus negative 4, negative 8, and negative 4. All right. So let's see what my final answer is. 6 minus 12 is negative 6, negative 12. 12 minus negative 10 is plus 10, which is 22. That's negative 50. 9 plus 24, 33. Negative 10. This is negative 2. This is 38, and that's 10. There you go. That's my resulting 3a minus 2b. All right. So go ahead and figure out what 3 times a, 2 times b is, and then you can subtract it. Because you don't never know. I can ask you, I can ask different questions. I can say, well, what's 2b minus 3a? Then if you have this thing already written out, what the scalar multiple is, it's easier to then add or subtract. All right, multiplication. Multiplication is a little bit tricky, okay? So finding the product of two matrices is only possible, first of all, when the inner dimensions are the same, meaning that the number of columns of the first matrix is equal to the number of rows of the second matrix. So let's say if a matrix A is M times R, and second matrix is R times N, when the two inner dimensions are the same, that means these two are the same, then you are allowed to multiply the two matrices. Okay, and the resulting matrix will just be, all right, M times N. Okay, so think about this. This is 2 rows by 3 columns. This is 3 rows by 3 columns. Using my 2 example here. So when the two inner dimensions are the same, okay, then the resulting matrix, the product of the two, if I take A times B, then the answer will be 2 by 3 matrix. 2 by 3 times 3 by 3 will end up with be 2 by 3. The resulting is going to be 2 by 3. Okay, now, so the way how you do it, it's very important that you know what the dimension is on the resulting matrix, because the way how we actually multiply, what you do, you always think about row and column. That's why I do the introduction of matrix. The way how we read it is always go by row and column. So what you do is when you multiply, you think about the first row with the first column. So to obtain the entry of row 1, column 1 of the multiplication, so the resulting matrix from A times B is going to be located on, well, when you take row 1 and column 1, row 1, column 1, then that will give you a 1, 1 entry. Okay. Row 1, column 2, that means that will give you 1, 2 entry on the answer. All right. So what we do is take row 1 to go against with the column 1 by take the 1, 1 entry times the 1, 1, okay, times by the 1, 1 entry, plus take the 1, 2 entry times by 2, 1 entry. See how they reverse right here? And then take the 1, 3 entry plus the 1, 3 entry times by the 3, 1 entry. Okay, so once you multiply them and add them up, then that will be the 1, 1 entry answer. right. So this is to obtain the 1, 2 entry insert of A times B. So now this time we will take row 1, go with, let me use green, row 1, go with column 2. All right. So I take 1, 1 times 1, 2 plus 1, 2 times 2, 2 plus 1, 3 times 3, 2. All right. So that gives me 1, 2 entry. So on and so forth. So let me erase this real quick. How will I get 2, 1? How do I obtain 2, 1? If I want to get my answer for the 2, 1 entry, that means I'm going to take row 2, go with column 1. Okay, 2, 1 times 1, 1 plus 2, 2 times 2, 1 plus 2, 3 times 3, 1. All right, that's how I end up with the 2, 1 entry. Okay, a little bit of writing here. So let's go ahead and get started. All right, so this is what it will look like once I wrote out all the formulas. All right, property of matrix multiplication, real quick. Matrix multiplication are associative. Okay, I can multiply 2 matrices first, and then times the third one, or times the last 2, then times the first one. All right, scalar multiple is well, I can also do distribution. Matrix multiplication is distributive. Okay. No, matrix multiplication is not commutative. That means matrix A times matrix B is not going to be the same as matrix B times matrix A. Okay, it's totally different things, because then you will be taking row 1 of B go against column 1 of A. So the numbers will change. The number is very different with the way how we actually do the multiplication. All right, so why don't we just practice a little bit? Okay, let's find AB. If I get a chance, I can show you B times A. I'm allowed to do B times A as well, because here I got myself 2 square matrix. Both of them are 3 by 3. This is 3 by 3. This is 3 by 3. So since the inner dimensions are the same, then my resulting matrix will also be a 3 by 3. Okay. So let's go ahead and get started. This is a little bit tricky. All right. A times B. So started with the first entry. Row 1, column 1. I'm going to highlight row 1, column 1. So we take 1, 1 times 1, 1. 2 times 6 is 12. Plus. All right. 1, 2, 2, 1. These two multiply together. Negative 10 times 0 is 0. Plus 1, 3, 3, 1. Negative 2 times negative 5 will be positive 10. So my answer, A times B, my first entry will be 12 plus 0 plus 10, which is 22. Okay. All right. Let's do row 1, column 2. So think about this. Row 1, column 2. So that will be the 1, 2 entry for my answer. The 1, 2 entry on the answer is row 1, column 2. So that will be this one right next to the 22. So that will be negative 10. Excuse me. Start with 2 again. All right. 1, 1, 2, 1. Okay, if you don't believe me, you can look up here. 1, 1. Excuse me. 1, 1, 1, 2. I'm sorry. 1, 1, 1, 2. 1, 1, and 1, 2. Row 1, column 2. 1, 2. Hang on a second. To obtain the row 1, column 2. Oh, column 2. Row 1, column 2. 1, 1, 1, 2. Yep, I was right. 1, 1, 1, 2. Make sure my formulas are right. Yep. 1, 1, 1, 2. So that would be 2 times 10, which is 20, plus, okay, 1, 2, 2, 2, right? 1, 2, 2, 2. Negative 10 times that, positive 120. All right, negative 2 times 2, positive 4. So this is 144. All right. 1, 3. 1, 3 entry right here. 2 times negative 2, negative 4, plus negative 10 times negative 4, positive 40. All right. Negative 2 times negative 2, positive 4. So that's going to be 40. Okay. All right. Now, that's it for the first row, right? First row go against all 3 columns. Now, they do the second row. Second row, first column. So think about what I just said. Second row, first column. So that gives you 2, 1 entries. 2, 1 entries. Second row, first column. That will be this entry right here. So negative 4 times 0 is 0, plus 3 times 0 is 0, plus 10 times negative 5 is negative 50. So that would just be negative 50 here. All right. This one, second column. So this is 2, 2. Second row, second column, give you 2, 2 entry. Negative 4 times 10 is negative 40. Plus 3 times negative 2 is negative 36. 10 times 2 is positive 20. So that's negative 70 plus 20 is negative 50 again. All right. 2, 3 entry. All right. Negative 4 times negative 2, positive 8. Plus 3 times negative 4 is negative 12. Plus 10 times negative 2 is negative 20. So that's negative 22. Negative 22 plus 8. No, 32 plus 8. So subtract, that will be what? 24? Negative 24. All right. Third row, first column, 3, 1 entry. 4 times 6 is 24, plus negative 2 times 0 is 0, 2 times negative 5 is negative 10, so that will be positive 14. All right, second column, just be careful, okay? 4 times 10 is 40, that's positive 24, and that's positive 4, so that's 28, 68. All right. And the last entry, 3, 3 entry. All right, 2 times that. Excuse me, 4 times negative 2 is negative 8. Plus negative 2 times negative 4 is positive 8. 2 times negative 2 is negative 4. So that will be negative 4. Voila, that's my answer. Okay. Now I'm going to just do B times A real quick, okay? B times A, you got to be careful now. B times A means take first row of B times by first column. Okay, so that's why there's no commutative property, because I'm going to do different numbers now. So now if I do first row of B times first column of A, 6 times 2 is 12, plus 10 times negative 4. 10 times negative 4 is negative 40, plus negative 2 times that is negative 8. As you can see, this part is different than A times B. The 1, 1 entry going to have a different answer. Okay, so I just want to at least show you that much. telling, kind of reaffirming that the multiplication matrix does not have what? Does not have commutative property because you're using different numbers, okay? You're using different row and columns in a way to actually do the multiplication, okay? So I hope that kind of help you understand this multiplication, scalar multiple, and add and subtract of matrix a little bit better. All right, that will conclude this video. Thank you for watching.